So now the quotient rule. And with the quotient rule, this is the formula for the quotient. So we have y to equal to v. So v multiply du dx minus u multiplying the dx all over v squared. Please take note that with the formula for the quotient rule, the v du is rather common first, and the u the v dx follows. Unlike the product rule, because addition is commutative, that is why in the product rule, you can write u the dx plus v du dx, or v du dx plus u the v dx. But subtraction is not commutative, so you can't bring the u the v dx first and bring the v du dx later. No, that is not how you work on the quotient rule. With the quotient rule, take note that the v du dx comes first, so minus u the v dx. But with the product rule, because addition is commutative, you can bring the u the v dx first, and then v du dx follows. Okay, so let's consider this. And this is the quotient rule. And anytime you see a question in a fraction form telling you to differentiate, you're going to use the quotient rule. And you can see the formula is solved in the form of a fraction. So anytime you see a question in a fraction form, you are going to use the quotient rule. Now let's look at some examples. So we have example 1. So x squared all over 2x plus 3. So we have this question here, and this question is in a fraction form, right? Now how do you differentiate this? So let's differentiate our y with respect to x. Okay. Now if we want to differentiate this function here, we have x squared 2x plus 3. So as we did for the product rule, we know that the one common first is our u, the second one is our v. Same applies here. The numerator here is our u, and our denominator is our v. So we know that your u here is x squared, your v is 2x plus 3. Right? Okay. So let's differentiate u. So if you differentiate this, you are getting so the u dx. So if you differentiate this, we are getting 2 multiply the coefficient of x, which in this case is 1. So we have 2 multiply 1, and then x. So we subtract 1 from the estimate, and then we are getting the u dx to be 2x, right? Okay. Now let's differentiate the thing. So the v dx. So if you differentiate this becomes 0. If you differentiate the 2x, the exponent is 1. So 1 will multiply the coefficient to 2 by 1. So x to the power 1. So 1, you subtract 1 from the exponent. This becomes 0, as I said. So now the v dx, we are getting so, and then you get 2, right? Now you know your u to be x squared, your v 2x plus 3. And now the u dx, we have 2x, our the v dx, we have 2. So now let's break it down. So we know that our u is what? X squared. Sorry. So we know that our u is x squared. And then our v is what? So 2x plus 3. And when we differentiated the u, we had 2x, the v dx, we had 2. Okay, so now we have this. So this is how I arrange it. So as we do for the product rule, you multiply this again by the u dx again, and same. So you multiply the u by the v dx. But in this case, the v is coming first, so we bring the 2x plus 3, which is the v. So now this is our v. Multiplying our u dx. So we have 2x. But in this case, it's not addition. So from the formula, you can see that this operation here is minus. So minus u is x is equal to multiplying the dx, which is 2. Okay, so now this is your u dx, this is your u, and then the dx. So this all over, so as you can see from the formula, all over our b squared, so 2x plus 3 all squared. This you are not going to do anything to the denominator. You are just working out, you simplify the numerator and leave the denominator. Okay, so we have 2x multiplying this, we are getting 4x squared plus 6x minus, if you multiply 2 by the x squared, we are getting 2x squared. And since we have items 4x, we can put them to 4x minus 2x plus 6. And we are getting 2x squared plus 6. So this is the, so now we've simplified the numerator, and at the end we are getting our y to be 2x squared plus 6 all over 2x plus 3 all squared. And that is our final answer. If the question is in a fraction form, well, so if the question is in a fraction form, please take note that your final answer should also be in a fraction form, as you can see. So we had a question in a fraction form, we ended up getting a solution or an answer in a fraction form. That is how you go about the quotient rule. So now let's take a second example. To example 2, we can say x to the power 2 all over x to the power 3. So this is a very simple question. Let's see how to solve this. So we know that the numerator is our u and the denominator is our u. Now we know that your u is x squared and then your v is x cubed. So now let's differentiate u and let's differentiate v. So if you differentiate u, so the u dx, we are getting, so 2 multiply the coefficient, which is 1, so 2 by 1, x is equal to minus 1, we subtract 1 from the estimate. And we'll do the same for the v. So if you differentiate the v, we are getting, so 3 multiply the coefficient, so 3 by 1, and then x, we subtract 1 from the estimate. And at the end, we are getting the u dx to be, so 2 multiply 1, we are getting 2. And then for this one, you get x. So 2 minus 1 is 1. So x to the power 1. And then if you differentiate this or you simplify this, you are getting the u dx to be 3x. So 1 minus 3 or 3 minus 1, you are getting 2. So now this is our u dx, this is our u dx. Okay. So you now know that your u is x squared and then our v is x cubed, right? And our du dx is 2x, isn't it? And our v is, or the dx is 3x squared. Now you cross multiply. Now because the v comes first, we have x cubed multiplying our du dx, and that is 2x, right? So minus our u, x squared, multiplying the dx, which in this case is 3x squared. So all over our v, which is x to the power 3 squared. Okay, now we simplify the numerator. So the numerator, so if you multiply 2x by x cubed, we are getting 2x to the power 4. Minus, if you multiply 3x squared by x squared, we are getting 3x to the power 4. All over x to the power 3 all squared. And at the end, our derivative is going to be, so this minus this, we are getting negative x to the power 4 all over x to the power 3 all to the power 2. And that is the result or the answer for the second question. I believe you followed and you've understood the quotient rule now. Now our last rule is the chain rule. So now the chain rule. Now the chain rule, the formula is very simple, and that is dy du multiplying du dx. So this is the formula for the chain rule. So now let's take the first example. So we have the first example to be y equal to 3x plus 2 raised to the power 5. So anytime you see a question in this form, please take note of this type. Please, you are going to use the chain rule. Anytime you see that a function in the bracket is having an exponent of more than 2. So if it's no more than 2, and let's say it's in this form, so 3x plus 3 equal to, you can expand this and you can use the product rule to solve, right? But in this case, our exponent is more than 2. And if you try to expand, you will find it very difficult. So that is why we are going to use the chain rule. And this is how the chain rule works. So we are saying that 3x plus 2, the one in the bracket, is our u. And this entire thing here is our y, right? So we can write y as u raised to the power 5, isn't it? Okay. So now you know that the y is u raised to the power 5, and our u is what? 3x plus 2. Now we have our dy du dx, and you have your y, you have your u. So all what is left for you is to differentiate your y and differentiate your u. So because we have u here and y here, we differentiate y with respect to what? U to the y here. And we have the y here, right? Okay, so if you differentiate this is u is raised to the power 5. So if you differentiate u raised to the power 5, the 5 will multiply the coefficients of the u, which in this case is 1. So 5 multiplying 1. And we subtract 1 from the exponent. And that is going to be u raised to the power 5 minus 1. And then our dy du will be equal to 5 u raised to the power 4. So now this is our derivative of y. So we differentiated y and this is the result. And now let's differentiate our u. So if you differentiate the u, we are getting so u with respect to x. So if you differentiate this, because this is a constant, if you differentiate this, you are getting 0. And if you differentiate this, you are getting, we have x to the power 1. So 1 will multiply the coefficients, so 3 by 1. And then x to the power 1, we subtract 1 from the exponent. And at the end, our du dx will be 3. Right? So this gives us 0 and 3x. When we differentiate, you are getting 3. So now we know that our y is u raised to the power 5. Our u is 3x plus 2. And when we differentiated, we had our dy du to be 5u raised to the power 4. And then our du dx, we have 3. The thing is, we are saying multiply this and this, only this and this. So we multiply this and this. So 5u raised to the power 4, multiplying 3. So you multiply dy du and then du dx. So dy du and then du dx. And that is what we've done here. So if you multiply this and this, you have 5. So in this case, you are going to multiply the coefficient of the u. That is, in this case, is 5. So I'm going to multiply this by this. So 5 multiplying 3. Please take note of this and follow me as. Okay, and then we bring our u raised to the power 4. And in this case, we are getting 15u raised to the power 4. And that is the solution, that's the final answer for the question here. And if you want to bring the u back, it's fine. If you don't want to bring it back, it's fine, it's also fine. But all you need to do is make sure the u is correct, what you indicated in the question. So make sure what you do for the u is correct. And if you leave it in this form, you are good to go. But if you are not sure that your u is correct, you can bring the u back. So 15, we know that our u is 3x plus 2 raised to the power 4. You can leave it in this form, you can leave it in this form. And that is the final answer for the first question. So now let's look at the second question. So we have the second question to this example 2. We have 2x with the power 5. So very simple like this. Okay, now let's solve. We know that this is our u, so y is equal to u with the power 5. And then our u is equal to 2x. Right. So we differentiate our y with respect to u. We are getting 5u with the power 4. As we saw again, the same thing. So we are getting this, and if we differentiate the u with respect to x, we are getting x to the power 1. We multiply the coefficients, and we are getting 2 by 1, and then x 1 minus 1. Right. Okay. So now we multiply this and this, and we are getting 5u raised to the power 4. So we multiply the y du and then the u dx. Okay, so 5u raised to the power 4 multiply. So at the end we are getting 2x. When you differentiate, you get 2 because x is carrying the exponent of 1. So 1 minus 1 is 0, and 2 by 1 is 2. And so we multiply 5u raised to the power 4 by 2. And we are going to multiply the coefficient of the u by the 2 here. And at the end we are getting 10u raised to the power 4. So our final answer can be this, or we can bring your u back, which in this case will be 2. 10 multiply 2 is all over 4. And that is the final answer. And that's all for the 3 rules of differentiation. So if you are able to master these 3 rules, no matter how they say the question, no matter how you see the question, no matter how you find the question, if you understand these 3 rules, you can solve any question at all under differentiation. And that brings us to the end of today's lesson. So if you don't understand anything concerning what we've done today, please comment below, comment under the video, and I'll be willing to give you a feedback. So for now, we end our lesson here. Please don't forget to like, comment, and subscribe to my channel for more maths mastery. I'm Benjamin Dasso Kwame. Thank you for